class. Okay. So you need to we have learned sekejap. Alamak, salah lah pula. Okay. Awak belum lecture 1 jam lagi kan? I see. Okay. Salah. Okay, so this is your 1 hour lecture kan? Okay, so awak tak tengok lagi yang ni Okay, salah. So we will start with kinematics of linear motion. Okay, so yes, that is the motion. Okay, so kita ada komponen X and Y kalau yang 2 dimension. But for today's class, we are going to focus on kinematics linear motion. Okay. So which is one dimension. Kenapa tu? Ada orang nak masuk Class. Okay. Alright. Okay. So there are 2 types of motion. Okay. So one dimension. Okay, so one dimension is whether dia constant velocity, okay, uniform. Alright, or we have one dimension whether dia horizontal saja. Okay. Ataupun one dimension vertical motion. So basically we're referring to case yang free fall punya motion. Alright. So and then kita ada projectile yang ni bukan lesson untuk hari ni. Today we're going to see linear motion sajalah. Alright. So you need to know how to distinguish. You need to able to distinguish, define and distinguish distance and displacement. So what's the difference? Basically, distance is scalar, displacement vector. So and this is have the explanation lah for the exact. But when we want to distinguish it in term of the quantities, so this is basic scalar quantities, this is vector quantities. Speed and velocity, so also different lah kalau kita nak distinguish dia. Okay. Kalau kita nak explain on the distinguish between these two things, so memang dia different lah. Okay, so you may explain on whether dia adalah vector or scalar or else the definition of the speed and velocity. Secara je lah cerita sebab kadang dia jadi favorite soalan juga. Okay, so linear motion. So distance. So what is distance? So distance basically is defined as the length of actual path between 2 points. Okay, contoh we have this one kan. So length of actual path. So semua dia ambil kira. So arah ke mana pun dia ambil je lantak. Okay, so yang penting dia adalah length. So that is your actual path. Okay. So different with displacement. Please replace the displacement S2 dengan X. So because we guna X kan. Okay, so is defined as the distance between initial point and final point in a straight line. Okay, so displacement same unit. Okay, so maksudnya jangan kalau dia minta distinguish tu jangan please not to talk in terms of the unit. Sebab unit sama, distance meter, displacement also meter. Okay, so but if you want to distinguish, may explain based on the definition. Also can or explain the quantities itself. Contoh macam dia ada vector or dia adalah scalar quantities. Okay. So let's say we have this case. Okay, so object we move 30 meter to the east. After that, 15 meter to the south. Finally, move for 40 meter to west. Determine the displacement of P P relative to the original position. Ya betul kan? Kita belum kelas ni again. Aduh, confuse nya. Okay. So, dia kata object P move 30 meter to the east. So from here, from this point to this point, and then 15 meter to the south. So specific macam ni, and then displacement is adalah from starting to end point. Ataupun the shortest, panggil apa shortest? Shortest pass yang kita boleh sampai dari awal pada akhir dia. So that is how we explain the displacement. Okay, contoh yang ni, nampak tak dia bergerak tu? Okay, that one distance, tapi displacement adalah dari point O sampai point P. So how we are going to find the displacement magnitude of the displacement? So we are going to use the equation of theorem Pythagoras. Okay, so macam kita belajar vector tadi, now we are going to apply. Okay, so apply. So again, when we talk about vector, it must have magnitude and direction. So these two things that you need to careful, dua benda ni yang awak kena betul jaga-jaga. Okay, so bila dia about vector. So this is how we find the magnitude. Okay, we are not you are not allowed to simply add up all the value because that one akan jadi dia punya distance. So what you need to do is sum up the x component, the y component, and barulah kita and then use this equation, which is theorem Pythagoras equation, to find the magnitude of the displacement. And then for the direction, again, direction, why we use tangent. You need to know why we use tangent so that awak tak ada question, so that awak tahu where the angle of tangent, why we use tangent. We use tangent, again, saya explain balik sebab apa kita guna tangent. Okay, so this is because, again, we have triangle. Okay, so contoh, we have this angle here. Okay, so this is your vector. Let's say we have this vector R. Alright, so this is your resolution vector of y component. This is resolution vector of y x component. Okay, so this is your magnitude. So you already find using this one, this equation. So what's the angle? How we find the angle here? So kita akan gunakan another one rule. So just now, for x component, kita ambil R. Okay, saya biasa guna yang bahasa Melayu lah. So kita ada S cos, saya jadi K, tangent T lah. Saya biasa guna kalau cos, kalau saya sebelah X, kalau saya hantu. So dapatlah cos theta. Okay, salah. Kalau saya hantu, cos X over R. So that's why our magnitude X equal to R cos theta. Kalau saya hantu. Salah. Saya kena mula dengan sin. Okay, sin. Okay, sin. Sin apa dia? Saya takut hantu. So Y per R. So Y per R adalah sin theta. So that's why our Y component is R sin theta. Then for tangent, kalau saya hantu, cos tadi kan, tak takut tentang sangat. X, adjacent X. So Y per X. So that's why we get tangent theta. Okay, so this is where the tangent theta come from. So we use this tangent theta or Y over X as use to find the direction. Okay. So means that your angle, if you use tangent theta here, your angle adalah kena sentiasa di sini. Which means always sandwich pada x component. Okay, or else katalah awak ada, let's say, the vector, contoh kalau yang ini case-nya dia di sini, for first quadrant, for the second quadrant, the angle akan sinilah. Kalau dekat third quadrant, angle-nya di sinilah. For fourth quadrant, angle-nya di sini. So semuanya yang sandwich pada x-axis. Understand class? So I hope you understand that. Alright, so let's proceed. Bagitahu saya kalau saya laju sangat. Okay. So again, after you get your angle here, please don't leave this statement ataupun this, panggil apa, this apa? Nak kata explanation pun tak ada juga. Statement lah. So west to south ataupun awak nak ambil south of west pun memberikan maksud yang sama. Mana yang awak faham, mana yang awak mudah untuk explain this angle. Okay, or else you may draw. Kalau dah, sebabnya exam kan kita macam kadang kita tiba-tiba tak ingat. Biasa ingat je, tak ada masalah. Biasa kita lah jadi pakar rujuk. Tapi bila time exam tiba-tiba tak ingat. So tak apa, please don't be panic. You can just simply draw where the angle place. So simply draw, tunjukkan dekat examiner dekat mana your angle. Then awak dah menyelamatkan diri awak lah daripada awak tak tunjuk langsung. Sebab kalau ikutkan memanglah examiner nak tengok benda ni lah. Okay. Alright, next kita akan masuk the parameters. One of the parameters that important, the important parameters juga yang akan kita deal untuk motion. Okay, yang akan affect kita punya motion ataupun movement, panggil apa lagi? Okay, which is speed. Okay, but again speed, tengok ni, we define it as rate of change of distance. Rate of change of distance, okay, which is scalar quantity. Sebab distance scalar, time memang scalar lah. So what we get is kita classify dia sebagai scalar quantity. So change, basically speed is change of time, change of distance and then over time interval. So bila nampak change over ni, basically dia adalah apa ni, bila nampak 3 segi ni, dia macam adalah differentiation. Okay, so itu yang awak kena faham jugalah asal usul that equation. Okay. Alright, then velocity. Velocity is vector quantity. Why? Because we consider the direction. Ke kanan ke kita ambil kira, ke kiri ke dia ambil kira. The motion is going upward also we need to consider. Alright, but the SI unit the same with the speed. What is average velocity? So average velocity is the rate of change of displacement. So the rate of change of displacement, alright, different lah dengan tadi. Tadi rate of change juga, but of distance. This is, saya ambil definition yang paling mudah untuk awak ingat. Maksudnya awak tak payah tengok buku, awak tak payah rujuk mana-mana pun awak boleh ingat. So saya ambil simple word untuk awak supaya, tapi kalau boleh tengok buku lah, kalau boleh ingat ayat buku lagi baguslah. Nampak macam hebat sikit kan. Tapi yang ni saya ambil untuk yang for you to play safe. So that dekat mana-mana pun kalau orang tanya pun awak boleh jawab. Okay, every velocity tu rate of change. Sebab apa rate of change? Sebab ada apa? Sebab ada apa ni, time kat bawah. So anything yang kita bahagi dengan time, we assume terus dia akan jadi rate, one of rate lah. Kadar. So kadar perubahan tu. Okay. So semua yang S, please change to X. So X2 minus X1. Or in other word, we said that your final displacement minus your initial displacement. Okay, yang ni pun samalah. Time where you stop. Tak semestinya time where you stop. Maksudnya time yang awak nak pada masa itu. That time yang pada distance ini, displacement ini. Okay, minus your initial time. When you initiate your punya motion tu. Okay. So delta X over delta T. Okay, so direction dia akan depends pada displacement. So the displacement is vector, then your velocity akan ikutlah the displacement punya direction. Okay. But again, always remember, if the question asks you to find displacement, please mention the direction and magnitude, determine the velocity, mention the magnitude and direction. So always remember, it's defined as velocity, instantaneous velocity. So just now we have looked the equation for average velocity. So instantaneous, how we define it? Instantaneous velocity is the instantaneous rate of change of displacement, which is meaning that it cannot be equal to zero. Macam tadi ada salah satu masa dia zero, tapi sebenarnya maksudnya samalah. Dia kena ada perubahan masa dalam satu jarak. Okay. Ataupun dia macam ni lah, lebih kurang ds per dt. So an object moves in a uniform velocity when ds per dt equal to constant. Okay, contoh macam average tadi. Average velocity just now. Okay, so we get a constant value means that the motion ataupun the object moves in a uniform velocity. Okay, so apa ni dia kata? Instantaneous velocity equals to the average velocity at any time. Okay. Itulah maksud dia. Maksudnya kalau instantaneous tu dekat masa, dalam masa yang kita consider yang average velocity tu, contoh from time 1 second to 10 second. So we have an average velocity 1. And then maksudnya kalau kita kata the object move in a uniform velocity means that the instantaneous velocity, contoh pada masa 3 second dia masih the motion adalah that velocity. Pada 6 second dia masih pada velocity sebab dia masih dalam range time yang kita cari tadi tu. Okay, so now kita nak tengok dalam bentuk graf pula. So the gradient of the tangent of the curve at point Q is the instantaneous velocity at time T. So let's say we want to find instantaneous velocity. So cara dia tu macam lebih kurang average velocity juga. Okay. Alright. So acceleration. Acceleration also one of the important parameter juga that you need to consider when dealing with motion. Okay. So acceleration defined as the rate of change of velocity. So simple je lah. Sebabnya dia per dengan masa lagi. Okay, velocity per dengan masa, displacement per time. So we define it as rate of change of displacement. And now for the acceleration, we define it as the rate of change of velocity. So mudahlah untuk awak ingat. Okay, so kita divide dengan time, we get acceleration pula. Acceleration, pecutan. The pecutan. Sebab velocity boleh jadi constant saja. But sama juga, acceleration pun boleh jadi constant ataupun boleh jadi accelerate yang memang accelerate. Macam tu. Okay. So the direction akan sama dengan motion, which is the velocity itulah. Okay. So kalau this one is average velocity, average acceleration, then dia kata magnitude kalau at constant rate, macam mana acceleration is uniform. Okay, acceleration dia akan uniform kalau magnitude of velocity change at a constant rate. Okay, and along fixed direction. So which is, ini adalah definition pada acceleration tadilah. Okay, so tak ada apalah tu. Instantaneous. Oh, saya tak keluarkan saya punya pointer punya. Okay, instantaneous acceleration. Okay, so instantaneous rate of change of velocity. Maksudnya pada satu certain masa. Okay, so pada certain masa. Dia bukan dalam satu range masa. With respect to that time only. That is your instantaneous acceleration. Okay. Alright, so contoh. The different dengan, kalau tak nampak lagi ya. Sekejap ya, saya tunjukkan. Okay, so it's not the same dengan average velocity, average acceleration. Contoh, average acceleration, dia akan consider from when the object move from this point to the other one point, A to B. So dia move sebanyak acceleration average ni. Okay. Tapi kalau instantaneous acceleration, contoh dekat sini dia move dengan berapa acceleration? Acceleration pada masa ini. Dekat sini dia ada acceleration pada masa itu. That's why dia kata, but if the object move in a uniform acceleration, means that acceleration at time 1 here equal to acceleration at time 2 here, equal juga dengan acceleration at time 3 here. So means that it move in a uniform acceleration. Okay. So the deceleration is negative acceleration. Why? Because we use the deceleration to slowing down. So contoh kereta, kita brake, so kita ada daripada 5 meter per second squared jadi kosong. Okay. Jadi kosong, terberhenti. We stop our car, so we decelerate. But the motion still in that direction. But yang negatif adalah the acceleration sahaja. Okay, so motion masih in this direction. But the acceleration is negative sign, showing that it having deceleration. Why? Because bila kita ambil macam ni, our final velocity is 0 minus 5. So we get negative acceleration, or we call it as deceleration. So dia akan decrease, means that it occurs when the speed or the velocity decreases with time. Macam ni. Okay, so ini instantaneous acceleration graph dia. Okay, so now, pukul berapa ya? Baru 4:30. So graphical methods, displacement against time graph. Okay, so this is how we explain. Okay, the simple method on how we explain the motion. Okay, certain motion. So kita nak explain dia. So macam mana kita nak cerita ke orang about the motion of a car on the road tu kan, dia jalan. So berapa, how many, contoh 10 meter, okay, within 2 seconds. So how we are going to represent this motion? Using graphical method. So we have this graph. I introduce you the first graph is involve displacement against time graph. X jadi S jadi X. Okay, so let's say we have motion with uniform velocity. Uniform velocity is when the distance displacement akan increase with time. akan increase with time. What happened? We will get uniform velocity. Why? Because the gradient will give a constant value. Alright, and then we also may have this kind of motion which we have more than one gradient. The gradient increases with time. Okay, sama juga tadi increase juga tapi gradually. Okay, yang ni pun increase juga dengan masa. But for this case, the velocity akan increases with time because we have more than one gradient here. Okay. Alright. So let's say we have this case. PQR, we label it as PQR. So how we explain the motion at P? So motion at P maybe dia adalah it move with uniform velocity. What happened at Q? Q static. Nampak tak macam static? Sebab apa? Sebab it's not moving at that point. Okay, dia is not moving. Maksudnya tak ada distance, tak ada displacement. Pada masa itu, no. No different, tak ada satu range displacement pun. So at that point, so when we calculate the average average pula. The gradient equal to 0. And then at point R we will get negative. Yes, negative. Direction of velocity is changing. Velocity 0. Alright. And then kita tengok velocity versus time graph. Okay, so next one. We represent our motion using velocity versus time graph. Okay, so for this one, let's say we have uniform. For this first graph is to represent when you have uniform velocity. Contoh bawa kereta dalam jam 20 km per hour. Lepas 10 minit masih 20 km per hour. Bawa kereta dalam jam, tak boleh nak tekan minyak sangat. So maintain je macam tu. So this is how we represent dia. Tunjukkan dalam graf macam ni lah cerita dia. Saya punya motion tadi. Okay. And then for second case, we have uniform acceleration pula. Okay, tapi how to explain our velocity? Velocity kita increases gradually with the time. Okay, increases je, naik je velocity kita. But here kita cuma ada satu constant gradient. So macam yang ni, gradient dia equal to 0. That gradient represent the acceleration. Means that for case uniform velocity, the acceleration equal to 0. Banyak cerita yang boleh bercerita daripada from this graph. Many things that you can explain. Okay, uniform acceleration. Why? Because we only have a gradient here. So this a gradient showing that only this motion involve uniform acceleration from time 1 to time 2 sama je acceleration dia, tapi velocity dia bertambah from time to time. Next one, okay, kita ada case yang bit complicated. So involve ada tiga case, speeding up. So at first dia speeding up, lepas tu tengah traffic light dia berhenti kejap, lepas tu dia slowing down ataupun dia turun bukit ke. So dia dah tak boleh speeding up turun bukit laju pula kan. Naik bukit lah maksudnya. Okay. Boleh. So here, okay, kita tengok pula. So tadi kita kata the gradient represent the acceleration. But what is the area under graph represent? Area under graph represent the displacement. Okay, displacement. So daripada graph V tu kita boleh explain acceleration. Kita ada masa, kita ada displacement dah. Complete to explain our motion. Okay. For example, let's say we had toy train moves slowly along a straight track according to the displacement x against time t. Okay, so because of a toy train move saja, so we are not expecting suatu yang laju. So enough for us to have centimeter per second only. Okay, so at first, so dia kata, okay. So explain qualitatively the motion of the toy train. Explain qualitatively. Bila kata qualitatively, it's not involving the calculation. Okay, it's not involve any calculation. Just need to explain saja. Tapi to explain that, nampak tak dia macam tipu? Tadi kata kualitatif tapi ada nombor. Maksudnya kena calculate juga. Okay, so kena calculate lah kesimpulannya. Okay, why we need to calculate since dekat sini kalau kita nak kata the motion having constant velocity. Moving with a constant velocity. Okay, tak apalah. Dekat sini kita kata dia stop, contoh. Dekat sini kita kata moving with a constant velocity juga. Jadi these two explanation is the same. So tak best kan? So that's why bila dekat explanation you need to give the exact velocity. The constant velocity yang awak cakap tu dia move dengan constant velocity. Berapa constant velocity dia moving tu? And then the train stops tu no problem lah. Memang satu jawapan je lah. And then kalau kata constant same direction. Constant velocity. So berapa constant velocity dia? Okay, macam itulah. That's how we explain the motion of the toy train. Okay, B, sketch a velocity against time. So velocity against time, so this one is the graph for displacement against time. So you need to sketch velocity against time. So that's the where we use the information from soalan A tadi. Soalan A tu dah mention, okay, from 0 to 6 second, move with that constant velocity. So, easy for you to draw the, alamak dah kilap pula. Draw the, apa nama ni? Draw the velocity against time punya graph. So here is our first motion tadi. From time 0 to 6 second yang mana dia increase tadi. Kalau X tadi kan dia increase sampailah satu masa. So this when we plot dia sebenarnya memberikan satu constant value. Why? Because the gradient tadi kita dapat satu gradient saja. And then after that from 6 to 10 dia stop. And then from 10 to 14 second dia ada new constant velocity. So far so good ya kelas. Harap-harap tak tidur lah kat sana tu, macam seronok je nak hujan ni kan. Tidur ke? Tak suara dah. Nasib baik. Okay, good. Alright, so please stay with me. We have another 20 minutes to go. So I hope you stay with me, okay? Please give your full attention to me, only me, alright? Alright, so we move, we go to next question. Determine the average velocity for the whole journey. Average velocity. Bila nak average velocity, kita kena consider sebab dia kata the whole journey. So tak nak yang velocity sikit-sikit tu. Tadi ada 2-3 velocity kan. Ada 3 velocity. So we need to determine the velocity by Kalau ingat tadi equation yang saya tunjuk tadi, how to find the V average is you need to use X2 is your final displacement minus dengan your initial displacement at this time lah, at the period lah, period of time. So we get this average velocity. Okay. D nak apa pula? Calculate the instantaneous velocity at time equal to 12 second. Okay, instantaneous velocity at time equal to 12 second. Tengok macam mana dia buat. Tadi V average. So at time 12 second sepatutnya. Okay, so average velocity dari sini ke sini. Tapi dia nak okay, betul lah. Okay, so dia nak dari 10 to 14 second saja. So kita ambil lah the distance yang dia travel at that time, the displacement that the toy train travels at that time tu, I mean 4 second lah. But specific to the 10 second to 14 second tu lah. Alright, sebab bukannya 4 second yang awal tu. Okay, so we get this velocity which sebenarnya we already calculate pun this sebenarnya. Distance traveled by the train. So how we find the distance traveled by the train? Mana kita ambil distance traveled by the train? Okay. So, dia nak distance. Distance ke displacement dia kata? Salah. Distance traveled by the toy train. Okay, 10 meter. Kenapa 10 meter? Kenapa 10 sentimeter? 10 meter? Okay, so distance traveled by the train kita 10 sentimeter ke? Okay, we can macam yang dia cakap tadi. Okay, so we can use this area to find the distance. Okay, ini kalau distance. Distance ambil je area dia. Kalau the question ask you to find displacement, so need to consider yang the negative, positive of the ini kan tadi, okay. So we need to consider ataupun dekat sini dah memang tunjuk yang dia move sejauh ini 10 cm rasanya. So bukan 10 meter ni. Okay. Boleh juga nak cakap macam tu. Alright. Another one example. Lepas tu saya rasa habis kot. Sekejap tengok. Sekejap. Okay, sikit je lagi. Tengok satu example lagi. Train dah habis. Another one example, more complicated motion. You say we have this kind of motion pula. So here we have velocity against time. Okay, so a bit complicated. Ada kat sini dia naik. Naik sikit. Static sekejap. Turun pula. Static balik. Turun balik. Static balik. Naik balik. Okay. So many things that we need to consider here. But no problem. Kalau dah penuh ilmu di dada, bagi soalan apa pun, boleh je jawab. Okay, tak ada masalah kan. So again, describe qualitatively. Okay, so describe qualitatively The motion of the lift. Nampak ni lift tu apa? Lift tu yang orang guna untuk naik ke atas ke bawah. So bila naik ke atas ke bawah tu adalah dua motion lah. So satu ke atas, satu ke bawah. That's why kita ada yang negative part here. Okay. Alright, so how to describe this? Okay, so kita describe pada yang ada change lah. Janganlah describe from 1 second to 1 second. From 1 second to 1 second, nanti orang dah hantar kertas soal jawapan, awak tak hantar lagi. Sebabnya awak buat 50 second tu, awak explain berdiri. So tak payah macam tu lah. Okay, so see at only classify dia pada if the motion have changed. Contoh here, how we decide to explain? 0 to 5 second. Okay, so dia ada satu jenis motion yang kita boleh sekalikan. And then 5 second to 15 second ada satu jenis motion yang kita boleh explain kat sini. Which is kalau nak tambah markah lagi, kita letaklah berapa value dia. So move with constant acceleration kan, move with constant acceleration, satu constant acceleration, so berapa constant acceleration yang dia move kat sini. So kat sini ada A1, dekat sini A2. Lepas tu from 15 second to 20 second, satu motion yang lain pula berlaku kat sini. Okay, alright. So which is the acceleration equal to 0 sebab velocity dia mendatar je, no change to the velocity. So we can say that the acceleration at this time from 15 to 20 second, acceleration equal to 0. And then what happened? From 20 to 25 second, what happened to the motion? Nampaknya dia turun, okay, ataupun dia boleh kata decelerate juga. Okay, sebab kita akan dapat negative acceleration kat sini. Okay, tapi dia punya velocity masih constant decrease. Okay, velocity dia decrease. To explain the velocity decrease but moving with a value of deceleration negative, which is negative acceleration lah, deceleration tu. And then we have 25 to 30 second, dia stop, static, no acceleration, no velocity, no displacement here. So memang static kat sini. Okay, ataupun or else we can say it is in equilibrium state pun boleh. Alright, and then 30 to 35 second. Okay, so 30 to 35 second, so slowing down. And dekat sini kita boleh cakap motion dia pun menurun sebabnya dia dah below dari origin kita 0, then below than this. So the displacement dah negative. So kita boleh kata lift tu turun ke bawah. Okay. And then with an acceleration juga. So slowing down juga. And then dekat sini pun constant velocity, so move with a constant move with no acceleration, tak ada acceleration lah kat sini. And then dia naik balik up to one level sampailah dia pergi kat zone ni. Mungkinlah nak katanya dia naik kat tingkat 2, lepas tu dia pergi kat tingkat 4, lepas tu ambil orang kat sini, lepas tu dia turun balik, dia turun. Okey, lepas tu dia turun tingkat bawah 4 lah berapa lah. Okey. Contoh. Okey, so dekat sini you may list your motion tadi macam kita cakap. So lift at rest or stationary. So when you say that the lift move upward from rest, kena mention the constant acceleration because we have about beberapa time juga yang dia ada constant acceleration ni. So carikanlah so that your answer more specific, more precise, so your examiner tak ada sebab nak tolak your punya jawapan. That's the best things dah. Okay. Alright, now B, you need to plot graph acceleration against time. So acceleration against time, since you already explain all the motion here. Okay, so from 0 to 5, berapa ni kan. You just need to transfer all this into a graph macam ni. Okay, so transfer into this graph. Alright. Berlawan dengan azan pula ah. Sekejap ya, awak tengok dulu tengah azan kat sini. Okay. Alright. So we continue. So, okay, question number C. Okay, so C. Determine the total distance traveled by the lift and its displacement. Total distance and its displacement. There are two questions there. Ya kelas, tolong jangan miss. There are two questions kat situ. Total distance and its displacement. So macam mana nak jawab tu? So total distance is area under graph. Area under graph apa? Area velocity against time. Okay, jangan salah ya. So total distance. So kita dapatlah. So all the area under graph kita totalkan. Okay. Total distance, so we get 115 meter. Okay, kita tengok displacement. Sama juga area under graph. Tapi kita dapat sikit. Kenapa ya kelas? So what's the difference? Okay. I hope that you notice that. Okay, so bila distance, again, we are considering ke mana sahaja dia pergi, dia turun naik ke, kita consider. Okay, but the displacement, we are not consider, ataupun bukan kita tak consider, we are considering juga the negative tu. Tapi kita akan consider dia tolak lah. Dia tolak kepada that displacement because we are considering the direction. So means that that's why the displacement and distance we get unequal value. Okay, still the same. Where we get that value is just still from the area under the graph, but we consider the negative positive of yang ni. Macam mana saya dapat negative 4 ni is masih sama. Okay, nampak tak ni? Okay, so A1 yang ni, A2 yang ni, A3 yang ni, A4 yang ni, A5 yang ni. But here Nampak tak ni? Negative 4. So we need to include the negative here to find your displacement. Alright. So the acceleration apa disuruh? Okay. Apa ke? Calculate the average acceleration within 20 second to 40 second. Okay, mencabar juga tu sebab dia langkau beberapa tempat juga. So tengok macam mana dia buat. Contoh ya, kalau kita ada 2-3 acceleration kat situ, so we're going to find the average acceleration. Okay, so simply we use the negative 4. Negative 4? Betul ke negative 4? Negative 4 tu bukan ke... velocity lah kan? Negative 4 dekat situ, yang tu kosong. Oh, yang tu from 4. Okay, dia kata 20 second, at 20 second dia 4. 4. So initial 4, your final 4 and negative 4. So kita akan masukkan dalam equation average acceleration. Okay, so negative 4 minus 4. Initial velocity kita 4. So masa ni tolakkanlah daripada 40 to 20 seconds. So you get this one. Okay. So you get this one. Alright. So this is your acceleration. Average acceleration. So now kita dah masuk exercise. Okay, I think that's all for today's class. Ada apa-apa nak tanya tak? If not, then we continue tomorrow with more challenging punya topics juga. Uniformly accelerated motion. Kita akan berkenalan dengan motion yang kalau acceleration dia constant je. So we can form equation for that motion. So you just need to follow that equation, but dengan syarat your motion constant acceleration.